Okay, so this is week 13, Friday, our last lecture of the term. Okay, and then next week, you guys know already that Thursday and Friday again I'll be online teaching for revision for the final exam. Right. So we are going to go to 3D complete 3D mole circle, and we're going to go into yield criteria. Okay, so I'm going to continue where we last left off. We were solving this problem, right? So the solution formulate a lot of equations. We did not use equation. We visualize with mole circle, right? So the thing now is we want to calculate the stresses. We want to calculate stresses in the y direction. What are the two possibilities? Given a limit of the maximum shear stress to be 75 megapascal. So just to quickly recap, this is a material behavior which is a 75, and it's also equal to the radius, okay, maximum allowable radius. So we also calculate our maximum and minimum stress. So just to quickly recap, then we draw a box, okay, we draw a boundary, right? Then we calculate omega to find the stress average. Now someone asked me the pink, what is the pink over here? So it's just a sketch of, or pink ink, it's just a sketch of what I intend to carry out, okay, what we intend to do, okay. So to find to visualize, okay, what we're going to do. So that's why we calculate omega, and the purpose of omega is to calculate the distance from the x point to the stress average. So this is from the x point to stress average, okay, to the or center of the circle. Okay, so that's what we're trying to do. So we get an omega. Then after that, after getting omega, I realized something missing when I start plotting this curve. Hold on. So after we got omega, right, we are able to find the position of our average stress. Okay, so we found 2. So we found average stress 1 over here, and we found average stress over here. Okay, then from here we're able to calculate y1 and y2. And it's very easy to calculate y1 and y2 because all this distance over here, they are all our omega. Okay, they are all our omega. So from here, we are able to calculate stress y1 and stress y2. Okay, so when we look at stress y2, I wrote down here, it's not valid because it's outside the what? It's outside the operating boundary, yes or no? Right, it's outside the box. So it's not valid, okay? Whereas y2, right? If you look at y2, y2 is within the box, right? So y2 is a valid value, okay? So y2 is valid, right? And this is just by using mole circle. So if you look at the math that we have done, that's it, okay? So if you want to solve this mathematically, be my guest, okay? If you want to solve this mathematically, here you go. Oh, so this is the entire part that they solve mathematically. Go and have fun. Okay, we did not need to form all this equation at all. Okay, but our mole circle shows the same results. Okay, so what is common is they also calculate the stress average. Okay, over here they also calculate the stress average. So these two values are the same. So we have to compute our stress 1 and stress 2 value. So one of the valid answer is 68.44. Okay, and the other one is 196.88, which we also have calculated. Okay, 168, 168, or 196.866 and 56.866. It's the same. Okay, and the level of math we use, yeah, high school kids can do it. Okay, any questions so far? Okay, don't need to go through that complication. Okay, but in order to be able to apply what I teach down here, you need to be able to draw the operating boundary. Okay, what do I mean by operate? You need to be able to draw the box. Okay, so now let's construct the mole circle. Okay, for the valid one. Okay, so I'm going to draw the invalid circle. Okay, I'm going to draw the invalid, the circle that is not supposed to happen. Okay, So this is the circle, the maximum circle, maximum size of the circle, which has a radius of 75 megapascal. So if I bring it across to the invalid point, you can see what happens, right? You can see what happens. The circle is what? The circle go outside the what? The circle went outside. This area is outside the what? The operating boundary. Yes or no? So the material will fail. So that's why Y1 is not a possible solution at all. Okay, Y1 is like, no, it won't work. Okay. So if we go draw the circle for Y2 now, I'm going to use a thicker pen now. Okay, so this is the circle for Y2. This is the good circle. Okay, this is valid. Okay, so this is the valid circle. So over here now, what we have done over here. So this is our circle. Okay, this is our circle, right? For XY plane. And it's within the operating boundary, right? Why? Because if you look at the question, it has to satisfy the what? 75 megapascal. Okay, it has to meet the criteria. Okay, so now some of my eyes. Okay, Eugene, now draw for me 3D mole circle now. So I'm going to construct the three circles now. Okay, the three circles. Okay, so we know at point Z is when all stresses are equal to 0. Okay, so if I look at here, this is where my point Z is. Okay, so I'm going to draw the other two circles now. Okay, I'm going to do the other two circles. So 2, 6, 8, 8 and a bit. 4 out. Okay, so I'm going to sketch the other two circles. Okay, so this is one of the circle, right? And then this circle that I've just drawn, okay, this circle I've just drawn over here. Wait, let me use a different color because it's totally chaos now. Okay. So this circle over here, right? This circle over here belongs to XZ plane. Okay. Some of you say why XZ plane? Because at point X over here, this is the acute angle. Okay. Right, like what I taught before we go off when we finish our 10-20 class. Okay. Then I would like to draw another circle. So this is so the next circle is here. Okay. So this will be our Y Z plane. Okay, so if we are to label, this will be out of plane. This is also out of plane. And then this is our in plane. Okay, so that is our 3D mole circle. Okay, for the problem 7 point or our problem number 1 down here. Okay, now we only have found one value only. Okay, we have to find another one. Okay, we have to find another value. So we're not done yet. So I'm going to, before I go, any questions regarding this mole circle over here or this problem set over here? Anyone? No, I don't hear anything, so it's okay. Okay, now I'm not saying that you can't form all these equations. Okay, you can, but in order to form all these equations, you have to visualize this. Okay, that is how they form the equation. They have to visualize the circles like this. Okay, I can't do that. Okay, I only have a 2D mind. Okay, I don't have a 3D mind like them. Okay, right. So we're going to solve we have not done yet because we only have a y value, one of the y value. Okay, then we are going to find the other y value. Okay, still the same problem. Okay, we are still tackling the same problem set. Okay, so we have to find. Okay, we have to find the y2 value, right? So let me transfer what we know. So we know what is our stress max and mean, which is a material behavior, is plus and minus 150 megapascal. And it has to meet the condition where the maximum shearing stress is equal to 75 megapascal. Okay, so we need to find another point. Okay, we need to find our stress Y value. Okay, so we are going to do. Okay, so I'm going to draw again. I'm going to draw a scale. Now the scale I'm going to draw, I'm only going to draw half. Okay, I don't need to draw the whole length because now we know the limits. Or that was my purpose, to show you the limits. So we start with minus 160, 140. Okay, so normal stress, and then we're going to have our shearing stress. Right. So shearing stress, clockwise, counterclockwise. Okay, 20, 40, 60, 80, minus 20, minus 40, minus 60, minus 80. Okay, right. So I'm going to again draw the don't go area. Okay, so we cannot go beyond here. Okay, so this is our 80, 74. Yeah, we cannot go beyond here. Okay, so these are all our limits. Okay, no go. Okay, so this is also our limits. Right. So outside the red, right? We can't go outside the red. So we're going to again is 70. So the stress, X is at 70. Okay, stress X. Okay, this is our stress Z. And then we have our shear, and our shear is at 40. Okay, so there is our 40 line. And next is our 40 line. Right. Okay. So we already know the same thing, that this is our point X. Okay. We know that. Okay. So this is our point X, our point Y, and we know that this is our point Z. Okay. So over here, we also know that this is our point Z. Okay. Our point Z. So another way to find the other stress Y value, right, is to let, okay, we're going to let, okay, let stress mean, or we're going to let stress mean be the control, or stress mean, okay, we're going to let stress mean and tau max to determine the stress Y value. Okay, stress Y value. Okay. So what we can do now, okay, we're going to use that. So not only so the previous one was tau max was the control. Okay, so this one, tau max control, right? We let tau max control. We let tau max the maximum shear control, because we use the radius of what, 75. Okay. The next one, this one, we're going to let the stress mean and tau max control. What do I mean control? Means, okay, when we draw the 3D circle, okay, 3D mole circle, it has to touch the stress mean and tau max. Okay, I repeat again, it has to touch stress mean and tau max. So I'm going to call one of my point here. Okay, so there are two possibilities. Okay, I'm going to show you one possibility